Welcome friends. In this video on the design of combined footing, we'll see one numerical problem related to the design of rectangular combined footing. So let's start with the problem statement. Design a reinforced concrete rectangular combined footing for two columns A and B located 3.6 meter apart. The sizes of column are 400 mm by 400 mm and 600 mm by 600 mm. The loads on columns are 1000 kilonewton and 1500 kilonewton respectively. The projection of footing parallel to the length of footing beyond the axis of column A is limited to 590 mm. So this is important word for us, important digit either. So the SBC of soil is 280 kilonewton per meter square. Use M20 concrete and Fe415 steel. So in such problems, first and very important step is to write the given data. So we'll write the given data, what information is given in the problem statement, which will be helpful for us in solution of the problem. So they have given the dimensions, that is length and width of cross-sectional area, that is 400 by 400 mm for column A and 600 mm by 600 mm for column B. They have also provided the projection, which we call L1, which is 590 mm, because of which we have provided the combined footing. So we have discussed about this in the previous video, which criteria are responsible for the selection of combined footing. So this criteria was included in that. This is because of restriction of projection of footing. So we have provided the combined footing because of restriction of projections of footing. Fy is 415 Newton per mm square. Distance between centers of column is 3.6 meter. FCK, that is grade of concrete, is 20. So value of FCK will be 20 Newton per mm square. Grade of steel is 415, Fe415, so Fy will be 415 Newton per mm square. Load on A is 1000 kilonewton, load on B is 1500 kilonewton. So this is the given data. Now we have to move towards the problem. So in the first step, we'll calculate the total load by adding the self weight of footing. But as we know, they have not given the self weight of footing because the dimension of footing are still unknown to us, because we have not determined the depth of footing. So for the sake of solution, we'll assume the weight of footing equal to 10% of load on columns. So I have taken the self weight of footing equal to 10% of total load on load on column. So the 10% of total load on column will be 10% of 1000 plus 1500. So I have calculated that 10 by 100 into 2500. So finally I have got the self weight of footing as 250 kilonewton. So we'll assume the self weight of footing equal to 250 kilonewton. Now we can calculate the total load on footing, which includes self weight of footing also. So that will be 1000 which is load on column, 1500 which is load on column B, and 250 is the self weight of the footing. So if you add this, you will get 2750. Now we'll go towards the next step. The next step will be to calculate the area of footing. Okay. I have told you earlier in the previous videos that if footing needs to be safe, then the ratio of external load divided by area of footing must be equal to or less than the soil bearing capacity. So if this is equal to or less than SBC, then the footing is safe. Okay, so we'll take the condition of equality P by A equals SBC, which is safe bearing capacity of soil. It means that if you want to calculate the area, what will be the formula? P by SBC. Okay, so same formula will be used here. So area of footing will be equal to W, which is total load, divided by SBC, that is soil bearing capacity. They have provided the value of soil bearing capacity, which we have written in the given data earlier. So that is 280 kilonewton. If I have forgotten to write that in the given data, you please add the detail in the given data. They have given this value of SBC in the problem statement. So this is the value of SBC. We know that total load is 2750 kilonewton divided by value of SBC is 280. So how much will be the ratio? So if you calculate this, you will get 9.821 meter square. Okay, so this is the value of area which we have calculated from the relation. Okay, now we have got the area of footing. Now next step is to calculate the length and width of footing so that we can move towards the next calculation. So in case of isolated footing, we have calculated the dimension of footing. In simple cases, we have considered square footing and we have calculated dimension of footing very easily. But in this case of combined footing, we need to do some calculations for determining the length of footing. So let's see how to calculate the length of footing. For now, we'll assume that this is our footing, required footing. Now they have provided the outer projection of footing from column A. They have given this length as 570 mm. Okay, they have also given the center to center distance between two columns, that is 3.6 meter. Now we know this part of footing. We also know the distance between these 2 points. Now the task is to calculate or to decide how much will be this distance. To decide this distance, we have to see some guidelines from the IS code, which says that the center of action of loading must pass through, or it should pass through the center of footing. So we know how much this projection is. We know what is the center to center distance between these two columns, but we don't know from where the effective resultant force of these two loads will pass. Okay, so that's why we need to calculate the point or section from which the resultant of this 1000 and 1500 load will pass. So it will be definitely in between these 2 points, but we'll calculate from where exactly it is passing. So to calculate the distance of resultant of these two loads, from this column we'll use the formula which will be written by me here. So it will be, if you are calculating the result distance of resultant from this column, you will take load of this column. So it will be like this: 1500 into distance between these two columns 3.6 divided by total load on column. If you are calculating the distance of section from this column, then you will take load on A here. So as I am calculating the distance of resultant load from A, so that's why I have taken load on B here, and this is total load on A and B, and this is distance between A and B. So how much will be this value? We'll calculate it. Let me calculate this. It is 2.16 if I'm not wrong. You just cross check the values. 2.16 will be the value. So it means that the position of the the resultant force from column A, center of column A, is at 2.16 meter from center of column A. So it will be at 2.16 meter from this point. It means the projection, so the part of footing from this edge to center of loading will be 570 plus 2.16. So 2.16 plus 570, it will be 2.73 here. Okay, as this to satisfy this case, we know that we must provide same dimension on this side of footing, because the center of action of loading should be equal to the center of footing. In order to maintain this as a center of footing, we should provide same dimension on this side of footing. So it means that this part of footing will also have length of 2.73. So if you deduct this part of this length of the footing from total length, you will get this projection of footing. So we'll just calculate that. Sorry, it will be 2.75 here. I'll correct myself. It will be 2.75 here. This addition will be 2.75. So again this will be also 75. Okay, now what will you do here? We'll just deduct this portion, this length of footing from 2.75 to know the projection of footing from the center of B. Okay, so if you deduct the value of footing, if you deduct this length of footing from this length, you will get this projection. Okay, so let's see how much it will be. First of all, we'll calculate this length. This total length is 3.6, so that's why 3.6 minus this 2.6, we'll calculate that. So this value 3.6 minus 2.16 will be 1.44. So this distance is 1.44. Okay, now we'll deduct this value 1.44 from 2.75. So it will be 1.31. So this projection will be 1.31. It is in meter. Of course, it is also in meter because this is in mm. So I have specified because this is written in mm. Now we have got the value of length of footing, because the half of projection of footing is 2.75, means length of footing will be equal to 2.75 multiplied by 2, which will be 5.5 meter. Okay, so we have got the value of length of footing. Now to calculate the width of footing, just divide the length, the area by length of footing. So the value of area of footing calculated by us was 9.821 divided by 5.5. So if you divide this 9.821 by 5.5, you will get 1.78 meter. We'll round it off to 1.8 meter. Okay. Now we have got the dimensions of footing. Next step will be to calculate the net upward pressure. If this is the section of footing which I am showing, which combined footing, this is the footing. We know that this footing is also experiencing some upward pressure from soil. So in order to calculate this value of net upward pressure experienced by soil, we have to we'll denote this pressure by P. We have to divide the total load on column, that is 1000 plus 1500, by area of footing which is provided by us. So that is provided 5.5 by 1.8. So this is how we'll calculate the net upward pressure, which will be 252.5. It will be in, load is in kilonewton, so that's why it is kilonewton, and the length is taken in the meter, so it will be meter square. Okay, so till now we have calculated the area of footing, length of footing, width of footing, and the net upward pressure. So as we know, there are some steps left for this design, but in this video we'll stop at this point. We know which steps are there for the design of footing. I will revise the steps. First we'll calculate the total load, then we'll determine area of footing with length and width, then we'll calculate net upward pressure, then we'll determine the trial depth by using criteria of bending or shear. Here we'll calculate with bending, then we'll take the checks for depth by checks for shear and one-way shear and two-way shear. One-way and two-way shear. After that, we'll design longitudinal and transverse reinforcement. So this is how the next steps of problem will be. So in this video we have solved the problem till this step. We'll see the next step in the next video. Thank you for watching this video.